There's an exam question on this particular exercise every year. So it's called function notation and identities. And I suppose they're just kind of rules that we can follow. Now, some of them are intuitive, like this log law here. So we should know that log ex plus log ey is the same as log exy. Okay, so if you've got, say, log e2 plus log e3, we know that that's equal to log e6. So this is what we call an identity. Okay, so we can summarize that in the following way. So f of x plus f of y equals f of xy. And let's just see how that works. So we've got this one here, which is if f of x is log ex, then it's that. And then we can see that if we've got f of y, then we're just going to replace this x with a y, and that is that thing there. And then all we're going to do is put this xy into this f of x here, and what that gives us is this thing here. Okay, so this is called an identity. We also know the identity for log ex take away log ey is you simply divide the number being logged. Alright, if f of x equals log e, yeah, so this is just the thing in summary. So f of x is this thing here, so that is that, f of y is that, and then when we put this into there, it becomes that. So let's just try a few out. For the function with the rule f of x equals 2x, verify that f of x plus y equals f of x plus f of y for all x and y. So really, all you do is you do as you're told. So we need to do f of x plus y, where f of x is this. So all we're going to do is write down 2x plus y equals f of x, which is 2x, and f of y, which is 2y. Now to verify it, all we do is expand this side. 2x plus 2y equals 2x plus 2y. Alright, so therefore verified. Alright, let's do another one of these. If f of x is 1 on x, show that f of x plus f of y equals this. So again, all I do is I just do what I'm told. So I've got 1 over x plus f of y is 1 over y is the same as x plus y multiplied by f of xy. So that is 1 over xy. Okay, so this right hand side is going to equal x plus y over xy. Now, how are we going to get this to happen? Well, I can see here that I'm going to times this side by y. I'm going to times this side by x to create a common denominator. So I've got y plus x all over, this is xy and xy, so xy, which if I reverse those around, I've just got x plus y over xy equals x plus y over xy. Alright. Okay, for the function f of x equals e to the x, give the identities for these. Alright, so let's do this one here. So f of x plus y equals e to the x plus y. Now we know that that, okay, is the same as e to the x, and we think about the index rules here. This is common bases being, so what's the rule? So it's e, or let's go back to like x to the 2 times x to the 3. So common bases being multiplied. What do we do with these powers? Okay, well in this case here we would go x to the 5. We would add them together. So what we're going to do is just say that this is e to the x times e to the y. So common bases being multiplied together, we add the powers. So that's the same as that. Now, I know that e to the x is simply this, f of x. And I know that e to the y is the same as f of y. Okay, and so therefore, I know that that is f of x plus y. And let's just finalize it or write it more formally. F of x plus y equals f of x f of y. Alright, so that's the identity for f of x plus y. Now let's do f of x take y. Okay, so that's e to the x take y. So when do we subtract? When common bases are being divided. So we can see straight away, there's f of x, there's f of y. So we're going to summarize this as f of x take away y equals f of x over f of y. So that's the functional identity. Alright, so this is the really common application of this, is they ask it as a multi-choice. So the function f has the property this: for all non-zero, which of the following is a possible rule? Alright, so what we're going to do is define the rule. So I've got the instructions down below in your notes. So all we do is define it. So I'm going to go define f of x equals x squared. So I'm just trying out the first one. So I wouldn't have a clue which one's the rule, and I'm not going to do the algebra for all of it. Okay. Right, so all I do now is literally type in the identity that they've got up here. So I'm just going to go f of x take away f of y equals y take x times f of xy. And basically, if it doesn't say anything, okay, then we're going to assume that this is false, okay? And it's only when it's true does it say true, okay? So imagine I tried it for f of x equals x squared plus, actually I will, right? So all I'll do is go back and redefine the function, x squared plus x to the 4, and then just ask the identity again, and all it does is it spits it back out to me, okay? And so it's not going to be until, and I know that this is the answer because I'm looking at my own notes down there, 1 on x, the hyperbola, and then I'm going to do the identity, and that's brilliant. It didn't tell me that it's true, and why not? Define as 1 on x. Was that the one that I've got as correct? Did I write that wrong? F of x take away f of y equals y take x times f of xy. That's stupid. Yeah. Oof. Okay. Well, yeah, best I leave this in just so that you can see why this is a really, really bad video, but a good video in a way. All right. So you can see here that this one is true. Now, what have I forgotten? Well, I'm going to go back to the first question. Okay, f of x equals x squared. And then I'm going to go back to the first statement. You can see here what's wrong is I've written down f of xy, and when you stick two letters together, you need to make sure that there's a multiply sign between them. All right, so it's still going to do the same thing, and in the end, I've been kind of lucky that I've picked this up. Okay, yeah, don't forget that when you are using two letters next to each other, you need to put that multiply sign in. So might be worth just writing that in your notes. I did it right here, so it's funny that. So I've defined it, and then over here, don't forget multiply. Okay, because if you just write xy, it defines it as one single variable called xy. Right, so try out a few of those identities in 7D and see how you go.